Welcome to this multilingual event. It's a series of summer webcasts and roundtables with different aspects of the language translation industry being discussed by people who hopefully have something interesting to say. This particular session is focused on the continuing evolution of Enterprise MT, and it includes three speakers, including me, who will discuss various aspects of the technology as it applies to business translation focused capabilities in particular. We'd like to thank MemSource, who is the sponsor of this event and a few more of the summer series. And we'd also like to thank the Kudo platform for hosting this event electronically. And they are also, I'm told, making this presentation available in 3 languages. And those 3 languages are Chinese, English, and French. So we are all going to endeavor to speak slowly so that the interpreters can do their work more easily. Let me first introduce the speakers before we begin. So we have 3 speakers here today. Chris Wendt is from Microsoft, and he's the group product manager of the Microsoft Translator products, which include, I think, implementations all the way from consumer implementations to lots of enterprise applications as well. And he's been a long-term player in the machine translation industry, and I'm sure you have seen him on many forums, discussing different aspects of the technology. Alon Lavie is the manager of the Unbabel's US AI lab based in Pittsburgh. And he's also another veteran of the machine translation industry who's been involved in many, breakthroughs in the research side, and also has worked in some of the largest implementations of machine translation around. He's been around for 20 years, I see on his biography here, and he's a research professor at the Language Technologies Institute at Carnegie Mellon as well. And then we have Joern Wuebker. He's the director of research at Lilt. And Lilt is an AI-powered enterprise translation software and services company. And prior to joining Lilt, he was a senior research scientist at RWTH Aachen University. And he's also worked at Microsoft in the NLP group. So we have a distinguished team of people here that are going to hopefully shed some light on the issue of machine translation. So I'd like to start first with a question on how enterprise MT differs from just generic MT. We're all aware that machine translation is now very pervasive. There's many estimates say trillions of words being translated on a daily basis. Much of that is the random internet user. And I'd like to sort of focus this particular session more on the enterprise aspect. So Chris, can we start with you? And when we say enterprise MT, what does it mean to you? And what are specific characteristics of it?
When we offer machine translation to enterprise, the typically first question is how secure is the translation? What are you doing with the content that I'm submitting to you for translation? There is the aspect that whoever performs the translation, even if we do it automatically, the system that does the translation has to decrypt the content and see it in clear text, and then translate it and then send it back to the customer, to the client that requests that translation. So typically, one of the first questions is, okay, what are we doing with the with the data. And there is a significant difference between consumer offerings where the provider has some claims some rights on using that content for product improvement. And on an enterprise offering, that's not acceptable, right? The provider is not allowed to do anything or to even see that data. So the customer is asking us to prove to them that we're not doing that. And we go ahead, we do that. We undergo audits and inspections to make sure that no human at the provider can see the data, and that we are not maintaining any of that. So they want to have the guarantee there's no residue of whatever I translated at the site, and we don't want Microsoft or anybody else to see that or profit from that. So that's typically the first question. The second question is, how can I influence the translation that you are providing to me, and that goes in the direction of customization. So what are you offering that allows me to predetermine how I want to have stuff translated in these languages? We go back and say, do you have some translation memory or some dictionaries that you can use? And then we provide an interface and methodology for them, for the customer, where they can go ahead and use that material to build a custom translation system that is respectful of their terminology and style. So those are typically the two top questions. Then the next then is a variety of different questions. What's your service level agreement, and what is your regional representation? Can I say my data never leaves the European Union, or never leaves Australia, or never leaves the US? And then we can hopefully answer that positively or not, and saying, well, maybe you cannot translate it in Australia today, but you can translate it in Singapore. If you trust Singapore, then we guarantee that that we will perform your translation in Singapore, and it's not going to leave that location. Then further is the throughput. If I have a batch request, how fast can you translate that? Those are the typical enterprise related questions, and that a typical consumer would not be concerned with, right? If I do a translation in my consumer facing tool, I care less about these things.
Okay. Alon, could you add anything to that would make it more enterprise specific?
Well, I think Chris kind of addressed a lot of the sort of dimensions or requirements that enterprises typically have. I think in a lot of the work that I've done, certainly, and where I'm most interested, the dimension that we try to most focus on is the issue of delivering highest quality, highest accuracy translations for the use cases that are important for the enterprise. A lot of that has to do with correct translation in context, in particular content types, in particular domains, in particular use cases, particularly in use cases where the machine translation is used directly by the enterprise without actual human involvement or translator involvement, whether it's post-editing or interactive or any other type of human involvement, but certainly also in cases where there is that interaction with humans. But some of it is also about being able to correctly handle the kind of structures of content that enterprises typically process, meaning it's not typically just simple plain texts you know, in a sentence by sentence format, but structured documents, highly marked up documents with HTML markup, with XML formats, certainly business formats, presentations, sometimes even PDF, where content is extracted from PDFs. A lot of businesses use a lot of structured documents in different formats. So being able to handle those for the purpose of translation is a major issue and requirement for enterprises. And then, of course, the things that already Chris addressed with respect to scale, speed, volume, are major concerns. I want to point out with respect to like security, what Chris addressed, part of it is just the secure communication from customer to the supplier or the vendor of the service, but part of it has to do with meeting privacy, you know, increasing privacy requirements and regulations. So in our case at Unbabel, for example, we pay a lot of attention to identifying personal identifiable information and capturing it, you know, abstracting it and removing it from the parts of the process where it's important that it be kept basically hidden or not disclosed to third parties. In our case, even human translators and editors get abstracted versions of personal identifiable information so that we don't compromise the privacy and security of that information. So, for example, credit cards or other, you know, credit cards, people's names, even. We identify different classes of personal identifiable information, and we abstract away from it for the purpose of translation. And you have to do that, of course, in ways that don't undermine the quality of the resulting translation. So that's a challenge. So maybe I'll stop here. There's, of course, more to say, particularly on customization and adaptation. I'm very eager to have a conversation about that.
I will go into that, yeah, right.
Yeah.
And Joern, can I get a comment or two from you? You know, I think Chris and Alon have covered this quite thoroughly, but maybe you have some particular things to say as well on this.
Yeah, I think when it comes to enterprise translation from a from the point of view of Lilt, that means basically the highest or the highest goal is the quality of the delivered translation. I mean, and in order to get there, you have to use the machine translation system in the right way, and that means in an interactive fashion with a human in the loop, right? So the human guarantees the quality, and the interactive part is to make it the most efficient and to reach the highest quality. And the second part, which has also been touched or already discussed, is the adaptation part, where you have to adapt the machine translation system to the specific content of the enterprise, to their terminology, to their kind of corporate identity language. And what we have found is that the most impactful adaptation here happens specifically on the document level, meaning what we have to do is you have to make the machine translation system learn while the translator is working from one sentence to the next. And this has the highest impact on the final quality of the MT and also on the efficiency of the translator.
Okay, so I'm keeping on this theme of adapting generic stock engines to the enterprise's unique needs. Can we continue to talk a little more about, you know, what is realistic in terms of adaptation and, you know, tailoring and the technology, the engine's capabilities to the specific enterprise needs? I just saw a presentation in the last week or two, an experiment done at Taos where they took several languages and you know, tried it on 7 or 8 different platforms, and the result that they presented in this particular presentation was that the custom engines made little or no difference, and that the stock engines were as good for the most part, except for German, interestingly, but in all the other languages, they said. So anyway, I'd like to dig a little deeper into, what do we mean by adaptation, customization? What makes it meaningfully better? Like, what are the key drivers? So Joern, can you start with that?
What makes it meaningfully better? I mean, basically, as I said, I don't know this exact evaluation, but I'm not too surprised about that result because, as I said, this kind of offline adaptation, meaning adapting with data that is kind of similar but not from the same document, has less impact on the adaptation quality than the one that if you learn from the translator as they work. And so, like, the most relevant information that the machine translation system needs to ingest is basically short-term or short-distance context and specific terminology that appears a lot within a single document, for example.
See, so in your platform there is interactive, dynamic kind of relationship, right? In the way your engines evolve and tune into the organizational's specific core requirements.
That is true, yes.
So that means you sort of limit yourself to localization use cases then, right? Because if you're going to translate 5 billion words, how does one really have humans involved in 5 billion words, in the loop?
Well, we are focusing on the content that really requires high quality.
No, that's fine. I just want to clarify that. Well, yeah, I mean, Alon, do you have any comments on on the adaptation, the customization? Like, how do we make it more predictably better, so that from the outset that you're going to have better results?
Yeah. So I mean, I think Joern was referring to a specific scenario where they have humans really in the loop interacting with the machine translation, and you're right to point out, Kirti, that that's relevant to only some scenarios and use cases in enterprise settings. But and you referred to that study that Taos did in was presented a week or two ago. And just to put in context there, when you talk about stock engines, it's basically, these are basically cases where machine translation systems for a particular language pair are adapted in advance for a particular domain or vertical, such as travel or business or technology or things of that nature, versus custom engines, which you refer to, which are basically then taking an enterprise, narrowing down to a specific enterprise and further adapting a machine translation model to the terminology or the content specific within that vertical of a particular enterprise, and whether that additional adaptation step has additional value. And there were some questions as to whether, in this day and age, that additional level of adaptation does have value. I think, I think that particular study, has some limitations. I wouldn't draw necessarily broad stroke kind of conclusions about the value of adaptation all the way down to a specific customer level just from there. And it's important to just understand that, those were done on curated benchmark kind of test sets from those domains, which, are again, valid at one point in time. I think what characterizes, in my opinion, the enterprise setting, which sheds lights on this situation, is that enterprises' content actually constantly evolve, even if they operate primarily within a particular vertical domain. Say they are a travel-related company or a financial-related company. They're constantly, the content that they're translating is constantly changing over time. They're not translating the documents that are translated yesterday or last month over and over again, because those have already been translated and they can retrieve those, they can store those. What they typically need to send to MT, if they're doing things, effectively and smartly, is new content that's being generated. And Therefore, this static idea of stock engines that are not evolving is somewhat problematic, because the quality that you can expect from those types of things, those types of models, is going to diminish over time unless you go through a process of continuing to adapt those models. Now, Joern is in a particular situation where they can adapt, instantaneously, because they actually have the machine translation in the hands of translators. And that is relevant for certain types of situations and use cases. But in more general situations and use cases where you do want to leverage even machine translation without the intervention of humans and translators in all times, it is important to actually have ongoing content-related adaptation for specific enterprises because of that content drift phenomenon that I was articulating. It's just inevitable, and we've seen this again and again in all of the work that I've done, over the last in the enterprise settings. That's critical.
Okay. Yeah, Chris,
I can share that our customers achieve an average of 10 blue points improvement over the stock engine on their domains. I agree with what Alon described here, that that delta decreases over time unless you refresh it occasionally. So all our customers, the average is 10 blue points, which is significant. A human can easily detect a 10 blue point improvement. Many of the customers, they work on a relatively narrow domain, right? A narrow domain meaning there's not that much variability in the terminology, and the terminology set may not be particularly large. Example of a very narrow domain is weather reports, right? It's always the same words in different, pretty much the same contents or limited set of contexts. But if you look at larger domains, say if you have a larger enterprise, say Microsoft or Volkswagen or Toyota or something like that, they have a lot of terminology, and it is important that that terminology transfers correctly into however it is terminology is standardized in that target language. And that's really the largest benefit of the customization, that you can maintain the terminology, and for many enterprises that is very important for their corporate material.
If I could add just one more point, Kirti, here,
Sure.
Just to put some context here. I think we haven't really explicitly pointed out how immense the progress has been with neural machine translation technology over the last couple of years. I mean, it used to be that this question of customization adaptation really had to address issues with just fundamental issues of grammaticality and fluency of the translation being generated by the underlying MT technology. And it's not the case that we've completely solved those. Certainly there's a lot of variability, and there's still cases where machine translation with our latest state-of-the-art neural models still sometimes generates, even incomprehensive, uncomprehensible translations, or ones that have significant mistakes in them from a grammaticality and fluency. But that has dramatically changed over the last 2 years. So now it increasingly puts the spotlight on in the realm of enterprise adaptation, really on things like getting the terminology right, getting the style, getting the branding information correctly translated. And I think that does change the picture quite a bit. So I think it's important to keep that in mind.
In discussions about adapting and customizing MT systems, the issue always comes around how much data do you have to steer the engine a certain way to make it more accurate on my specific content. And the kind of data we're looking at, there's typically three kinds of data: translation memory, most often coming from localization, which may be completely unrelated to the specific need of the machine translation, the use case involved, or it comes from glossaries and terminology lists. And more recently, people like Lilt are doing much more direct interactive feedback, human feedback that steers the engine dynamically. So no, all this presumes the more you have of this data, presumably the better these engines are going to be. But what most people don't have a lot of this, of any of this kind of data. So what do we do when we don't have enough data? So Joern, can you start with that?
Right. So I basically this directly, or I can more or less repeat what I said earlier. We don't actually need all that much data. What we need is very, very relevant data, and the most relevant data is coming from the same document. So we've seen that like we can more or less saturate the adaptation quality after about let's say 500 sentences that have been translated. Right. All your old translation memories won't really make all that much of a difference anymore once you have adapted the system on very recent, very local document level translations.
Okay, so Chris, do you have anything to add to that?
Well, it's very easy to start. Let's start with your company name, your product names, the things that your products do that you want to have represented in a certain way, that whatever your local marketing has already decided they want to call this functionality by this term, just provide a dictionary. Just go with that. That's the simplest, and there's no minimum. You can have one dictionary entry and then customize. I wouldn't recommend that, but you can start like that, and then you do what Joern describes. You have a human translator review the highly relevant content, and then you get a stream of input that you can then periodically use to retrain the engine, or immediately retrain the engine as Lilt does it. Right? Mm-hmm. Yeah.
Alon, you have anything to add to that?
Yeah, I think it's important. I fundamentally agree. I mean, it's not really a matter of having huge volumes or very large volumes of data for adaptation. That kind of in the older kind of view of things, when we actually build static systems that are not really adaptable on an ongoing basis, maybe in those cases the static data has more importance. But even there, it's important to note that the adaptation types of methods and technology that we use, I think across all of us here, are not ones now that are typically suffer from the fact that you only have thousands or a few hundred thousands of segments from the enterprise that's drowning in billions and billions of background data. The techniques that are used both for training customer-specific models and then for adapting them, continuing to adapt them over time, are designed basically to focus on the differences and on the unique things coming from the customer, focusing on the terminology, focusing on the correct use of language for that customer, and taking advantage of that in generating appropriate translations going forward. I think one of the interesting things over the last couple of years, along with this current generation of neural translation models, has been developing technology that is particularly set on integrating in effective ways things like the terminology that the glossaries and the terminology resources from enterprises that Chris and Joern referred to, with the way that the neural models are actually generating the translations. So, we're beyond the simplest ways of just overriding, the translations generated by a model with something suggested by a terminology list. We actually have techniques now that are much more effective and actually combining basically constraints coming from terminology, accurate terminology, glossaries and things like that from customers with the translations that are generated by our machine translation models.
Okay. Yeah, go ahead.
I have one more addendum to this.
Sure.
One technique that you can use and that I increasingly recommend is to make it demand driven. So as Alon described, the machine translation quality, the raw machine translation quality is pretty good as it is these days, at least I would say in the top 20 languages, right? There's a steep fall off after that, below the top 20 languages, but in the top 20 languages, the machine translation quality is pretty good. So you can dare to publish some content that may not be your highest relevant content. You can dare to publish it raw, right? You get the customers, you get your subsidiaries, you get somebody tell you this is crap, right? This is bad. At that point, you have telemetry in place that tells you that somebody found this bad, or 10 people found this really bad, right? So at that point, you go ahead and human translate this. You can use Lilt for that, right? You can human translate it, and at that point, you have your training material in hand, right? And you grow it continuously. And the next time you translate this or similar content, you have a better result. So this the demand-driven human translation that automatically provides you with the most relevant training material.
Okay. You know, one of the strategies I've heard people mention is to manufacture data, to actually manufacture parallel data or specific variations of terminology data to make a model more robust. Is that something that you think has validity? Any of you?
Why would you do that? Yeah, please.
Well, I think there's different notions of manufacturing data. I mean, there were providers in the past that talked about actually like manufacturing training data and just adding it to the training data used to train the model to begin with. I think those techniques are maybe less relevant today, but there are interesting methods in training of the underlying neural models to make them more robust by introducing different types of synthetic phenomena into the data, by making the data deliberately more noisy in certain ways, for example, to deal with user-generated content or things of that nature, or just introducing deliberately certain types of mistakes and making the model aware of those types of mistakes. So there is some aspect of that I think is quite interesting of generating, you know, interesting controlled types of data and leveraging that data in effective ways and making machine translation models more robust. I mean, one of the things that most is very commonly done nowadays in a lot of these neural models is called back translation, basically adding training material that's generated by taking authentic material in the target language, usually in the enterprise relevant domain, and translating it back to the source language using another machine translation model, and then leveraging that material in training the model that's going basically in the other direction from the source language to the target language. And that's been actually quite, in some cases, or initially quite surprisingly effective, but I think we understand a little bit more now why that's so effective.
Okay. You know, one of the issues we have been grappling with, and you know, so is the localization industry in general, is about quality. And the machine translation quality has been hard to measure after this neural wave began. And you know, people still use BLEU scores all the time. And you know, just like Chris said a few minutes ago, that you know, when people adapt, they see a 10 BLEU score improvement. But do BLEU scores really tell you if things improved? You know, I mean, the human discernment is a critical element, but how do we solve this? You know, like if you want to, you know, there's a current thinking. One of the kinds of thinking I've seen, like in, you know, that Intento has generated is that, oh, you find the best German engine, then you find the best French engine, and you find the best Chinese engine, and then you mix and match. And even though they may have totally different kinds of responsiveness, totally different kinds of implementation, data security, all the big enterprise things don't fit across, you know, this kind of cross section. So, Joern, how do you look at what is quality? Like, how do you tell if my engine got better? Or is it better than the other competitive engine? How do you tell this? In a meaningful way, like, because if you look at one sentence, is not a meaningful in terms of machine translation. Machine translation is usually used for hundreds of thousands or millions of sentences. So yes. From that context, how do you do this?
Well, basically, first of all, when you evaluate a machine translation engine, you have to look at the right type of data, right? You have to look at the data that you're basically translating. So it has to be either in domain or similar to the data that you want to translate, or even better, it has to be the data that you're translating. And secondly, obviously, you have to find a metric that is specifically tailored to the use case. And well, at Lilt, we're focusing on human-in-the-loop interactive machine translation, and that means we can actually we have a metric which is next word prediction accuracy that we can just measure in production on all the data that is being translated, and it gives us a meaningful score of how good the engine is. Right, we get a percentage which tells us this is the number of words that were provided by the machine as opposed to the linguist. And the higher that percentage, obviously, the better the machine translation engine. And in production, like on total average at Lilt, we're about at 75% for that, meaning 75% of the words are produced by the machine. And we can also see that, we can also observe that the adaptation that we're doing has a significant impact, meaning we can do the same evaluation with an unadapted baseline model. And we see that this average is around 60%. So that means there's a gain of 15% that we get by doing like this from one sentence to the next, learn while the translator works adaptation.
Okay. Chris, do you have comments on this? Sorry.
Well, what's the purpose of producing a translation? Just ask yourself that. Why do you translate this stuff? What's the desired effect? It can be user engagement, right? You want your user to engage more on your platform. You want the user to buy the product. You want the user to be able to solve a problem on their own without calling my support department. Right, so ask that, produce a translation. I mean, that's the most relevant metric of translation quality. Did it solve the problem? Did it answer the question? Did it sell the product? That's where one needs to start. Measure that. We have the internet. It's all easily accessible. We have metrics in place. And then look at where you have deficiency. You can do an A/B test with a human translation and a raw machine translation. Measure the delta. If the delta is small enough, well, maybe you don't need the human translation. Right? When the delta is big, you have a pretty good indication that you still need a human translation for this type of content, or maybe just for this particular article or group of articles. So that's the most relevant metric. How does the user react to the translation? Of course, if you translate a book that is printed, you don't have that feedback mechanism, but wherever you have that access, that should be the most relevant. But I agree with what you said, Kirti, in the beginning. With today's machine translation quality, BLEU is not particularly meaningful. The benefit of BLEU or similar metrics is it is cheap and automatic. Relevant is in, say, I would say a laboratory evaluation. That's as opposed to the real world evaluation. What I just talked about was a real world evaluation. As in a laboratory evaluation, human evaluation is what counts. The problem with human evaluation is that it's slow and expensive, right? But you can do it. Just ask humans what you think.
And often improperly done.
Oh, that too, yes.
Oh, Alon, you have
I'm very passionate about machine
about this
translation
common
evaluation.
stuff. Yeah, we can talk about that.
And we've been, I've worked on it for a long time, but I think it's important really to distinguish use cases. I mean, when we actually are putting out translations for raw machine translation out there, for different use cases, of course, it's important for that customer in enterprise setting to know basically, is it fit for purpose? And ultimately, human evaluations, which there's of course different methodologies that have been developed for that. Of course, LSPs have been doing a long time linguistic quality analysis methods, but an industry kind of emerging thing, standard over the last few years has been sort of a framework called multidimensional quality measure, or MQM. And we actually do a lot of human evaluations using MQM to detect and classify and annotate the errors actually that are being generated by our machine translation systems. And that's actually created, those human annotations has created then interesting data sets on which to evaluate machine translation, but also in creating data to generate improved automatic measures for measuring the quality of machine translation. So I completely agree that Bleu has become, basically almost useless in most of the the use cases for evaluating machine translation systems that are interest to us, which are fundamentally end-to enterprises. When you're comparing different models and you want to know, should I actually go with model A or model B, or for provider A or provider B, things like Blue scores right now are not typically insightful enough. And for us internally, when we're actually developing customer-specific machine translation models for our customers and then retraining those, we have very specific problems of saying, is this retrained model actually better than the model, that previous version of the model we had in production, and should we deploy it? So, and we've discovered we cannot, we can do human evaluations, but they're expensive, they're slow, we can't do them, they don't scale enough, they're too costly and too slow. And using Bleu and older traditional established metrics for that has proven to be just not informative enough. Just correlations with human judgments and MQMs are typically very, very low. So we have exciting news. Actually, we've developed a neural based evaluation framework and new metric that's trained directly to predict MQM scores. And it's performing remarkably well. It's a framework and a metric that we've called Comet. We haven't really published a whole lot about it yet, but I will just say that our intention is to release this as an open source metric and to advocate for broad adoption of this as a new automated metric to measure machine translation quality in particularly in commercial industrial settings, but also in research settings. And you'll be hearing more about it in the next few weeks and months. It's in our interest actually to get a new automated metric that has much higher level of correlation with human judgments, and in particular can make fine distinctions between very high performing models like we have now with neural models, like Chris was saying earlier. When we have, for the top 20 languages, neural models are translating really well. We want to still be able to make distinctions whether this new version of this model actually is better than the previous version, and Comet seems to be able to do that. So I'm very excited about it, and you'll be hearing more about it from us soon.
Sounds good. Joern, I want to give you some time to talk about this issue as well, because Lilt often gets left out of these generic engine evaluation kinds of studies. And, I know from looking at direct feedback from customers and from seeing, the output, that often, as you pointed out, that very few, very specific in context and relevant amounts of data improve your engines very rapidly. So when an engine is moving and improving dynamically, how do you measure quality? Like, how is it the, you know, engine is dynamically improving on an interactive basis, you know, maybe even every 5 minutes, every 10 minutes?
Yeah, right. So basically, because we are doing this, like, basically we are measuring we are learning from every single sentence, but we're also measuring the quality on every single sentence that is being translated, right? So our engine is specifically designed for this interactive use case, to be used with a human in the loop. And that means on every single sentence that is being translated with it, we always ultimately get the correct translation, and we know on every single sentence how well the engine did. And we're just looking at these prediction accuracies over time, and then we can see that basically if we compare the graph over time from the adapted engines or compared to the baseline unadapted engines, we can always see this gap of really, it depends on the customer, on the language pair, on the specific content, but on average, there's a gap of about 15% that tells us that the adapted engine is really better than the unadapted one.
So 15% as in productivity improvement, or 15? What do you mean by
15%? This is basically the word prediction accuracy. That means how many of the words that end up in the final translation, as approved by the translators, have been produced or suggested by the engine, as opposed to having to be typed by the linguist.
Now, recently there's been lots of excitement about this thing called GPT-3, you know, that predicts the next word and can do all kinds of magic stuff. And how, you know, so like, does that threaten what you're doing in any way? Because, you know, they're claiming they can write programs, they can write letters, they can do machine translation, they can do everything.
Well, GPT-3 is trained on so much data that, and also it's inherently monolingual, right? It can predict text, but it's not necessarily good at translating.
Okay.
And therefore, it's not really threatening what we are doing. The next problem is that GPT-3 is such a huge model that just like latency of predictions is so slow that you wouldn't be able to use it in an interactive fashion.
Okay, I'd like to just shift now to discussing when we move beyond localization and use machine translation for like really high volume stuff, that, you know, translating stuff that would just not get translated because it's not feasible under any localization scenario, you know, because there's just too much, it comes too fast. It's, you know, the volume, like in e-commerce, the volumes are in billions of words a month. So in these kinds of scenarios, where human in the loop is a luxury, or it has to be very strategic, Chris, what would you say? You know, like, isn't this where most of the growth is happening with machine translation use?
Well, that is certainly the interesting growth, right? Machines today translate about 1,000 times more words every day than humans do. So in that sense, that is the higher volume use case, right? About 1,000 times higher volume. And that's where we can make a difference. For the enterprise case, it is of course on what we. Let me start differently. You mentioned the e-commerce scenario where the enterprise translates the user-generated content, right? The merchants for an e-commerce platform are the generators of the content. It's not the platform itself generating that, right? So the e-commerce platform just acts as the acts on commission of the original provider, right, to translate the content. But you also have the enterprise's own content, and we call it the extent of localization, right? You have so much content in the original, say, in the headquarter language or the original creation language, and then you have per locale, you have that much smaller portion of it that you have in translation. The application of, say, raw machine translation is to increase the extent of localization for the segments of the content that you didn't consider before, and that may be helpful for the audience. So I'm generally advocating, look at the extent of localization that you have, find the gaps, and choose the areas that you think may be useful, or that you don't know whether they're useful, and just go ahead with it, publish it, and see what happens. What is the feedback that you're getting from your audience? Do you get the engagement that you are seeing? You're already present in that market, but you give them only that little content to deal with, right? If you increase that, what happens? For user-generated content, to tie that up with your previous question, for user-generated content, the customization is not particularly effective. Right, because users don't follow your company glossary anyway, right? So you are pretty much stuck with the stock engines there, but you may be able to do some tweaks there. Say if you are an e-commerce company that wants to grow the business in fashion, for instance, right? You want to make sure that all the brand names in fashion and so translate well, and then you can start with some content, or maybe with a dictionary to make sure that segment of your translations actually work well. Mm-hmm. Alon had a comment on that.
Yeah, Alon,
well, I think that it's a really interesting question about, like, beyond use cases of localization. There are some very dramatic ones. The e-commerce one was mentioned, where there's just volumes, but I want to focus on more communication types of scenarios. I mean, we've been extremely focused and successful on kind of customer support and customer service types of use cases. And what distinguishes those are communication scenarios, that's content that typically would be considered having, in some sense, shorter shelf life. It's not necessarily content that's translated, at professional quality and is going to be out there for very, very long periods of time. So in those types of scenarios, I think it's really important to actually have good ability to make decisions as to what can go out in raw machine translation quality and what actually does, where the value is from bringing humans into the loop. And so we put a lot of focus on that, and it ties into our conversation earlier about measuring quality. But in this case, we're talking about measuring quality in real time, basically. What is the actual translation quality of a translation that's been generated, and making a decision about whether you can send that directly to the end consumer in raw form, or does it need to go for human editing? And so, in some cases, the scenario itself dictates whether that's even feasible, right? If you're in a multilingual chat scenario between a live chat scenario between a customer and an agent, and you're actually performing machine translation for that scenario in real time, you don't even have the opportunity or the time to send it to a human editor to fix it in most cases. But we found that in our products we have use cases where there is a short SLA, but in customer support, there's a request coming in. It's perfectly fine to respond to the customer within an SLA of a few minutes, or maybe 30 minutes or something like that. And there we can actually make those distinctions about whether to send in raw form or to send it to one of our editors in our community that will fix something either at the sentence by sentence level or at a total complete response level, and will generate the right response for the consumer, for the customer. And so we also make distinctions there between the inbound, which is what Chris was referring to more, which is user-generated content that is more difficult to control, and how to actually, what kinds of adaptations or techniques are actually useful for that inbound request content versus the outbound content from customer support from our enterprise customers, which is much more controlled and carefully, and needs also to be at professional levels. And so there's actually more room for both human involvement and also careful control and adaptation of what's being generated on the outbound from responses, basically, in customer support. So that's a customer support scenario. I think there's also other interesting type of scenarios, such as monitoring social media, business intelligence, finding what your customers think about your products when they're talking about them in multiple languages. Companies, enterprises using like user forums basically to solve their customers, their consumers' problems, and enabling those to be multilingual. So in all of those scenarios, these are non-traditional localization scenarios. It's very interesting to look at the dynamics of how machine translation in raw form can solve those problems, and actually putting in place technology for quality estimation, meaning understanding the quality of raw machine translation in real time in order to make intelligent decisions about whether to send it out, whether to send it to editing, and so forth.
Okay. In my experience also, I've had some use cases where the term I formulated, I don't know if you all agree with it, but it's linguistic steering. This is post-editing. So if you have a corpus, say you have 200,000 descriptions of hotels around the world, and that's a database, and it's 25 million words, and you want to translate it into 5 languages, and you need to do it quickly because that's what e-commerce, real world, business reality is in that business. So you can't translate 25 million words across, the whole corpus. So what people do is they triage. They say, okay, 5-star hotels will get full post-editing. We'll go through the Lilt treatment, and 4 and 1-star hotels, some of it will just really raw machine translation, because we don't care. But the linguistic steering and how it's different from post-editing is, rather than translate every single one, you say, okay, what kinds of phrases are very common? And so you spend 90% of your efforts on the 10% high density stuff, like Hotel A is a short walk from Times Square. It's a short walk from restaurants. It's a short walk from the train. So a short walk from becomes a very critical term that you want to have properly understood, because it across 200,000 hotel descriptions, it probably occurs tens of thousands of times, maybe. So, doing this kind of analysis of corpus and identifying high density phrases and saying that let's get these right, because if we get these 1,000 phrases right, it raises the whole level of the whole corpus up, in the translation. And then we know that something has to have big human touch and some things need less human touch, but it raises the overall quality. I mean, what do you think of strategies like that?
I think they make sense in many cases. The way we usually think about this is actually putting together very dedicated types of test suites for certain types of customers, for certain types of domains, that are designed to test basically how well our machine translation systems are doing on very specific type of linguistic phenomena, such as the one that you were focusing on, and measuring those. So it's not just like taking a sample of documents or text and just measuring quality across there, identifying errors there, but looking, do we translate, named entities in the right way? Do we actually translate units and measures correctly? Do we actually, in financial domains or getting the price correctly, right? You don't want to, even in a hotel listing, if it's $100 a night hotel, you don't want to translate it as $1,000 a night hotel by mistake, right? Those are critical errors. So by establishing specific types of test suites of pertinent type of content, you can actually make sure that you do well on those particular dimensions.
Okay, great. We're just about. Yeah, go ahead.
One more thing, and then why are you afraid of raw machine translation? What's the danger in raw machine translation? The danger in raw machine translation is not the occasional grammar mistake, or let's say not so fluent translation. The danger is in a catastrophic mistake. We call it a catastrophic mistake that has the chance to, say, destroy the reputation of the publisher or the merchant or something, or is highly offensive, like offends a large percentage of your usership. That's the danger, and you don't find that with say targeted linguistic or linguistically targeted pre-work. You find it really only with having metrics in place that allows you to see that you produced a catastrophic mistake and then react to it quickly, right? Before it spreads even further. And that points back to having business intelligence in place that tells you that you may have produced a catastrophic mistake, right? And like the $100,000 or $12,000 issue is a catastrophic mistake for that particular hotel because nobody's going to buy that, right? So that falls into that category, and we need to be able to avoid that. And linguistic screening doesn't help with that. But having business intelligence.
I don't know that I completely agree that linguistic kind of screening is completely, the whole point about it is to basically put the spotlight on certain critical types of phrases or components and try and make sure up front that we do a reasonable job. It's not a guarantee, of course. We could still make catastrophic errors. Machine translation still every day makes many catastrophic errors. I think Chris and Joern will also agree with me. But we can try and minimize that or by focusing on specific type of phenomena. So I think that the truth is somewhere in the middle, Chris.
Good, okay.
The one thing that I would like to mention here is that basically this example that you just gave, Kirti, is pretty much a great example for why I would like to challenge the original premise here. And the premise is that human translation or human in the loop translation doesn't scale. And this example shows very well that you don't even have to do this kind of linguistic pre-screening or pre-selection, because if you do it in the way that you just start translating and then all of these very common phrases will appear multiple times. They will be corrected by a translator multiple times, and the engine will automatically learn to correctly translate these. And over time, when you go through the content, the predictions will get better and better, and the work that the linguist has to do gets less and less. And thus, this way, the human in the loop technique actually does scale to a pretty high degree and to much more than has historically been possible. Meaning the original premise that we should, there's kind of a limit to what can be translated in human quality. Like this boundary can be pushed a lot if you use technology in the right way.
Mm-hmm. Okay, great. Talking about technology, there I don't see a lot of questions on the message panel, so I'm going to, move on with just where the technology is evolving. There's lots. NLP is one of the most exciting areas of research, and a lot of the most interesting AI stuff is happening in the NLP area. And recently, there have been two big things that have happened. That Google had a hand in both of them, but there's many people involved. And one's this thing called BERT, which tends to focus more on understanding large blocks of text, and understanding in the sense that we can even say that humans understand. There's semantic grasping of core concepts, and when you understand things, you tend to be able to make deductions more accurately. That's the premise there. And there's this new GPT thing where there's this frenzy right now about, oh my God, this can write code, it can write apps, it can, do machine translation, it can write letters, it can write resumes, it can do just books even. It has failed on poems, but lots of, there's lots of examples of really amazing stuff it does. And there's also many now coming out where they're not so amazing, that it's very easy to foil these capabilities. But given this massive improvement in language generation, language understanding, and machine translation is one of those pieces, and most human communication problems and business communication problems involve understanding, rapid generation and the translation. It all has to kind of come together. Do you see how? Where do you see how this stuff going in future? Joern, let me start with you. You're scaling the human at the most aggressive way. So let me ask you.
I mean, they can certainly play a big role in improving pretty much any machine learning and any text processing model, right? So this is a huge advancement in any kind of text generation technology. But the thing about these is, you can design probes for these models that show that ultimately they still don't understand what they're doing. They're just memorizing things that they've seen on tons and tons of data, and then they're reproducing these. But something that requires real world knowledge, basic or deeper understanding of the text. In context or of the meaning of the text. This is something they typically are not able to solve, or at least you can show that they don't really understand it by designing certain adversarial examples where they would still catastrophically fail. So we haven't really solved the problem yet. This is just a big step in being able to use the hardware that we have with all these high speeds graphical computation units, and process so huge amounts of data and put it into so many million and billions of parameters that we can basically memorize so much that it appears as if it understands a lot of things, but ultimately, if you really look behind the veneer, then you see it's mainly just memorizing.
I want to just add an additional question into that, is that one way I see this kind of impacting machine translation, the world of machine translation, is source analysis. So if you have much more intelligent, much more informed at the machine level source analysis, then the machine translation optimization process could be more intelligent. I don't know. I mean, Chris, do you think that's something that makes sense at all?
I call this large language model applications. So large language models of any size are really have been essential for machine translation and for a long time, and they do help. I mean, or techniques that are used there can help. In source analysis, of course, what you could do is a classification and direct it to direct whatever the input is to the appropriately trained engine. What the large language models do well also is beyond sentence context, say whole document context. They can take that into account. In machine translation, we are getting into that space as well, and there's something that we can learn from these large language models and apply similar techniques. The large language models by themselves are not that good at translation, because the core language model for automatic translation needs to be multilingual, or at least bilingual. And in that sense isn't the same as these large language models, even though they claim to be able to do translations, but they're not they're not able at this point to compete with the multilingual systems that we are building, typically on a somewhat smaller scale. But say the aspect of the whole document context is just as important for translation, or I mean, is eminently important for translation. And there is an exchange of ideas on how we can grow that, say, the scope that the translation system looks at when it's translating a phrase or a sentence.
Okay. Alon, do you have anything to add here?
Yeah. No, I want to put basically a little bit of context around these massive scale models that you mentioned that started with BERT, and now there's GPT-3, and there's several other ones that are developed primarily by the big tech companies. So they're typically referred as pre-trained language models, and they're interesting because of this notion of being able then to take the model that has been trained on billions and billions of words and applying it to different types of NLP applications. And what's going on fundamentally underneath the hood there is the training of these massive models is generating interesting representations that can be reused rather than learned from scratch in any application, even like machine translation. What we mean, in fact, is that both at the word level, at the sentence level, and at different levels of granularity here, you're getting basically very deeply trained models with representations that fundamentally reflect meaning. And we're doing that now. What particularly interesting are the multilingual ones, where they're training simultaneously these same types of models on multiple languages. And the premise here, or the promising thing that hasn't been quite realized, is that these representations that are learned throughout these massive scale language models actually are representations of meaning that do have tight correspondences across languages. So we're not quite there yet, because as Chris points out, we can't use just GPT-3 or BERT or XLM as just a translation model. I mean, they can do that, but they don't do that as well as the specifically trained translation models. But that's largely because these representations are not quite mapped correctly across these different languages. But the promising here for the future is that these representations will be very accurate representations of meaning across different languages. And I think we will be able to move to a world that's somewhat more similar to the picture that we were envisioning 20 or more years ago with Interlingua, where you will be able fundamentally to have these big massive models that, rather than training individual pair by pair translation models of English to Spanish and English to Italian and Spanish to French and all that, we will be able to fundamentally take a source language, encode it using these neural models into a representation, and then from that generate with these models the corresponding representation on any target language that we choose. And that will be actually a major breakthrough. We're not there yet, but we are moving, I think, in a direction that is promising with respect to that. And these pre-trained models, meaning that we don't have to train our models from scratch, from start, basically from as if we knew nothing, but take the parameters of these models and then continue to update and refine them for particular tasks, is proving to be immensely important and useful across many different applications. And just as an anecdote, actually, it turns out to be one of the most important aspects of this new MT evaluation metric that we've developed, Comet, is actually it's built on top of these pre-trained models.
I see. So I have a question. Will this help with low resource languages? Since everything here, like it seems, like Chris, and we all understand that the top 20 languages have really pretty decent MT available today. But as soon as you go beyond that 20, I know for the Indian languages, it's pretty crappy, and and they say it's a question of data, but do these new technologies allow more rapid evolution, in the absence of data, do they allow you to, since you vectorize all the language understanding in some way, and you can apply it to Gujarati and Sindhi and Tamil, and then move much faster then?
To some extent, they do, with respect to leveraging the data that's available from related languages, similar languages, in some cases even unrelated languages. There's been really interesting research that shows that building multilingual models with even unrelated languages helps quite significantly in training machine translation models for low resource languages like that, rather than relying exclusively on the very small amount of data that's available directly between that language pair.
Right. Okay, I'm looking at some of the questions here, and these are pretty technical questions here, but okay, well, here's one. Thinking about cybernetics 2.0, how crucially is human feedback still relevant to NMT? So I think he's talking about surveillance of interactions, and so they just know what you're doing. You don't even need human feedback. Is that the question? I'm not sure.
I'm guessing this is probably directed at me, because we are like this human in the loop MT. The question is, are we going to need human translators for much longer? And I believe the answer is yes. The human feedback will be relevant for much longer, because in the because of the phenomenon that Chris or Alon, I don't remember, mentioned, is that the shift in domain relevance over time, right? So the domain always shifts a bit, and we will need to update our engines over time to really work well with the current content. Because of the fact that even the best engines still, in some cases, really have these catastrophic fails, I'm pretty sure that we will rely on human feedback for quite a while longer.
Let's also not forget that language is a living thing, right? Language develops over time. There's new terminology or shift in language, not just for the enterprise, but just for the target audience, right? And of course, you would want to enable the target audience members to talk to each other, or the enterprise to talk to them.
Yes. What machine translation system a year ago knew how to translate, or what is COVID-19, right?
Right.
Right. Exactly. Yeah. So here's one more question. How are pre-trained models addressing the constraints of agglutinative languages? So it means that language, I guess, in agglutinative languages you have 20 variations of the same sentence, or 10 variations of the same sentence. And so how does a pre-trained model understand those variations?
Well, so agglutinative, presumably, we're talking about linguistically about polysynthetic languages. A lot of particularly low resource languages are, don't reflect meaning, in the way that syntax and morphology and word structures do in the major languages that we've worked on in the past. So I don't know that pre-trained models are specifically, good or bad at addressing those languages in particular, but the same techniques that are used for training those language models, with the self-training techniques that are used, should work also on I think agglutinative languages, with some specific attention needed to be paid to how to actually pull apart the components of those languages. Words in those types of agglutinative languages, one word fundamentally can reflect the meaning of an entire sentence. The word structure is much more richer than in the languages that we typically are working on these days.
But also all of these models are working on so-called word pieces anyway right now. So that means it's kind of inherently handled in all neural machine translation models, as well as in the big language models.
That's right.
Yeah, and it's not new to any of us. Say Chinese is like the whole sentence is there are no word boundaries, right? No physically visible word boundaries.
So I think we're close to the end here now, and I just want to end with one final question that, to some extent, Joern has already answered, but Chris, we'll start with you. Do you see machine translation replacing more and more human translation?
It's kind of too late to ask that question now, right? Machines translate 1,000 times more than humans. That'll increase, right? It'll be 2,000, 5,000, 10,000 times more words in an increasingly communicating world. So machines translate more than humans already. I mean, it has happened sometime long in the past. That amount was surpassed, but it's humans that use language. It's humans that communicate to each other. Well, in some cases, it's machines communicating with humans as well. But the humans, language is inherent to humans. Natural language is inherent to humans, and that evolves, and that has emotion and behavior associated with it. That is very inherent to humans. So it's not gonna go away as long as there are humans.
Yeah, Alon, you have a comment on that?
Yeah, I think typically these questions are asked. Is the profession or the role of human translators, basically threatened or on the verge of extinction or something like that? And the answer, I think, in my mind, is equivocally no. I mean, the number of professional and non-professional translators out there is fundamentally limited. The volumes are way, orders of magnitude larger in terms of like the needs for translation and the opportunities for translation. So while it's pretty clear that the roles of translators are evolving, whether they're involved through a mechanism like Lilt applies, where basically they're interacting with machine translation in real time dynamically and generating the translations that are needed for their customers, or they're doing post editing after the fact on high quality neural machine translation, or they're in very specific use cases. They might still need to do translation from scratch, but there's going to be an ongoing, for the foreseeable future, role for human translators, for professional translators to actually make a living with their profession. I don't think anybody out there should be worried. They have to keep up with the technology. Their role might change. The way that they actually do their work might change. That's happening anyway. The way we're working today is very different than we worked, 4 months ago before the pandemic, right? So right. The world changes around us all the time, sometimes in unexpected ways. But I really don't believe that there's a threat or that bilingual contributors to translation, translators, professional, less than professional, are going to go away, or the need for them is going to go away.
I think an error that many of us in the technology area tend to make is when we talk about human translation, we make it this one monolithic thing. And just as machine translation can be varied in quality and capability and scalability and in all these aspects, human translation, I think also there are people that have deep subject matter expertise, that they understand what an executive wants to convey, even though he says it really badly, and they adjust it. I mean, imagine the people that are trying to translate for Donald Trump. If you translated what he said, it would be horrific. And so I'm seeing all these comments about the excellence of the interpreters that are working with us, and I think we tend to sort of gloss over that humans. There are people that are really good, and there are people that are not so good. And I think machine translation focuses on the people that are sort of in the middle, in the normal distribution. We'll replace everyone maybe in the 1 or maybe even as high as 2 distributions up, but we're never going to touch those people who understand the intent, the semantic core, and, the communication impact of it all. That kind of stuff I think is still really very specialized. I mean, I know Joern, you're the one of the technologists who really sees the value of humans, and you kind of see it, enough that you've made it a central theme of your whole technology approach. So I mean, what do you have to say about this?
Yeah, basically, I mean, the need for human translation will not go away, because it's the only guarantee to get really high quality translation, right? And what will change, obviously, is the amount of content that can be translated by humans, because they're augmented by technology at the same time. But at the same time, the amount of content that requires high quality translation will increase in the same manner, right? Because the amount of data, the amount of content is increasing very fast as well. And that means, yeah, as Chris said, as long as there are humans, there will be need for human translators.
Yeah. Okay, I think we've come to an end here of time, and thanks again once to MemSource for sponsoring this event and this webinar, and the recordings will be made available, so you can see it and watch it in different languages if you want, and listen to the excellence of the interpreters that have been working together with us through this session. Thank you very much.